Given a coefficient of friction of mu is equal to 0.90 for a car driving through a level turn with r is equal to 120 meters, what is the maximum speed at which the car could safely make the turn? Now, this situation actually, I think, fits really well the last example we looked at, where we looked at the free body diagram for a car and a turn on a level surface. So I'm going to maybe draw a quick sketch of the car. It won't be as good as I had it on the slide in the last example, but having just seen that, you can maybe use your imagination for what I'm trying to draw here. Maybe here's like the car window or something like that. Whatever. Here are some car tires, roughly. Okay, and there it is on the road. And if we're kind of maybe looking at it from behind, as we did before, and if it's turning, I guess it doesn't really say whether. I'm just going to assume a direction for this and say that's the acceleration, the direction. Maybe I'll put an a sub c, right, equals v squared over, v squared over r there. And the free body diagram we had basically had force of gravity, normal force, and it made sense that there had to be a, that's probably too long, hang on. There had to be a traction force, or maybe I can just say that this is a static friction force, so I'll call it F sub F. That's maybe the more way physicists would talk about it. And, a race car driver would probably talk about traction more. Physicist says static friction force. So there it is in my diagram. And really the tool, I think, for this kind of a question is going to be Newton's second law. So F equals ma, or really F net is equal to ma. And I've got, those three forces there. So F G plus F N are the two vertical forces, plus F F equals ma. And if I do this in a standard set of coordinates, x represents horizontal directions, and really I just have that force of friction is equal to that mass times the centripetal acceleration. So I'm already going to go ahead and put in v squared over r for that. For the y components, I'm going to put in a minus mg plus fn is equal to 0, which clearly implies that the normal force is equal to mg. Maybe I jumped the gun there because I'm already doing math and I haven't finished the physics yet, because one other piece of information that I think is crucial to this question is the relationship between the force of friction and the normal force. Now hang on, I said static friction, you might recall. So am I cheating a little bit? Because you might recall for static friction, the equation is not really an equation, but is actually an inequality. However, in the question, it says the maximum speed at which the car could safely make the turn. So in writing this equation, I've already assumed that we are at the maximum traction that is possible, which I think makes intuitive sense is going to correspond to that maximum speed. So I'm just making a, kind of recognizing that when I wrote this equation, I've already made some assumptions, but they are in alignment with what I am told. And I'm mentioning that, I'm stressing that because it's very important when you write equations, not just to write equations randomly and not know why you write equations or whether they're correct. You have to give thought to really every one. That's very, very important in physics to do that. But the helpfulness of this equation is in combination with this expression for the normal force, recognizing again it's just equal to the weight. I could substitute in here mu times mg, in other words just coefficient of friction times weight is that force of friction, and then that's something I can substitute into the original x component formula there. And actually, hang on, I want to do that substitution. So in other words, it's going to be that mu mg is equal to mv squared over r. And something to notice here is if you look at this question, right, what were we given? We were given coefficient of friction. Sometimes I start right off doing this, but this one I forgot. But let me just go back just to check in with what do I know and do I got enough. Is these were the only two numbers given to me, and sometimes, like if you initially listed that and you thought, hey, I'm going to do F equals ma, but how is that possible? I don't have m. But this is something that happens a lot. We've seen it happen, so we should get used to the fact that sometimes m's cancel. In other words, it doesn't matter how big this car is for this situation, which is maybe defies some intuition. Some people feel safer driving faster in a car that is big, but the laws of physics actually don't necessarily suggest that that necessarily works. And it doesn't actually. So anyways, can I solve what's being asked for? I'm really being asked for a maximum speed, but I think given the setup that I have, that means I'm going to solve for this v, and I can see from this formula that v squared is equal to r times mu g, which implies that v, of course, is going to be equal to the square root of r mu g. And so let's see, that means the numbers I'm going to put in is going to be square root of 120 meters times mu is just 0.9 is a pure number because coefficients of friction don't have units, multiplied by 9.81 meters per second squared. And I often wind up making my square roots too short, and then I keep extending them as I add numbers in there. I've put all that into my calculator, and it gives me like 32.549, etc. I feel like, though, maybe two significant figures is enough here, so I'm going to say 33 meters per second, as it looks like what the units should be. So let's go ahead and check that now and see if that was correct, and it looks like we did it, so there it is.